Sir, we're also supposed to write the line on top, yeah?
Yeah, what do you say? You're supposed to write what?
Uh, the entire thing, right? Not only the table.
Yes, you have to write this table only, the whole table.
Okay.
Because at least you must know that there are the five laws and the name of those. You must know.
Okay. I'm done.
So what does it says?
So can you go up? Done, sir.
Okay, whenever a chemical reactions take place, the mass before and after the reaction is always conserved. You cannot have any okay. If I'm saying that the mass law of law of conservation of mass, what does it say actually? It says that mass can neither be created nor destroyed during chemical reactions. So when we are reacting some substance, like for example, if you have calcium carbonate, if you are heating it, this calcium carbonate, you get calcium oxide plus carbon dioxide. Okay? So if it is 100 gram, you take this calcium carbonate and you heat it. If you get 56 gram of this one, then 44 grams of carbon dioxide will also be produced. So don't think that if you heat calcium carbonate for 100 grams, so you will get 56 gram, uh, only 56 gram of calcium oxide, which is solid. So actually the 44 grams of carbon dioxide will be eliminated out. So we say that total mass before and after. This is the before, okay, and this is the after. So it is always conserved. So mass can neither be created nor destroyed during chemical reaction. Total during a chemical reaction, the total mass of the reactor is always equal to total mass of the product. So this side is called reactant side before the arrow, reactant side, and this side is called products. So note it this one also, but I have written in the blue. Okay, and write down a definition for the law of conservation of mass. Fast. When you done this, that done.
No, sir. Second.
Mass of A plus B is always equals to mass of AB.
We'll have a doubt.
Yes, speak. What's your doubt?
So in the example you've given CaCO3, that one is the product, right?
No, it is not necessary. This is a type of decomposition reaction which a single substance is broken. So it is not necessary that if you can have a single substance, it can be broken into multiple, and a multiple substance can give you single product also. Okay. Like
Yes.
for example, if it is H2 plus O2 will gives you H2O.
Yes, sir.
So this is the reactant side and this is the product side.
Okay.
Product is always after the arrow. And if you have H2O, if you pass electricity to it, then it will gives you again H2 plus O2. So
Yes.
it is not necessary that you will have more than one product. Sorry, react. You will always have more than one reactant. No, you can
Yes.
have only single reactant.
Yes. I'm done.
Other stones.
Done, sir.
Okay. It is also there. That you can check it. If you have 4 grams of H2, but you check it that if you take the H2 plus O2 will gives you H2O. Okay, suppose you write, and you know that mass of one hydrogen atom is 1, one oxygen atom is 60. So there is two hydrogen atom, you will have 2. There is 60, 2 oxygen atom means 32. 16 into 2, 32. Okay, but you check it in water. Water is 2 hydrogen atom and 1 oxygen means 2 plus 16 is 18. 2 hydrogen का mass 2 because 1 hydrogen atom has 1 mass. So 2 will have 2 and 1 oxygen atom will have 16 to 16. But you see that it is not following law of conservation of mass. Not following law of conservation of mass. So अगर ये follow नहीं करा तो क्या करेंगे फिर हम इसको balance करेंगे. So we'll write it in such a manner that it will balance it like H2 plus O2 will gives you H2O will balance it. There are 2 hydrogen atoms, it is also 2, but it is 2 oxygen atoms, but it is only 1. Write 2 here. Now it has become 4. 4 oxygen, sorry, 4 hydrogen, 2 to the 4. And you can check it. If you check 4 hydrogen atom means 4 gram because one there are 2 H2. So 1 H2 have 2 mass, so 2 will have 4, and then 16 to the 32 grams of oxygen, and 18 gram is of 1. The 2 will have 36. One water molecule have 18 mass. 2 will have, because it is 2H2, it will have 36. So in this way, you can check it that 4 plus 32 is 36, then it is giving 36. So, okay, समझ आया?
Yes.
Yes, sir.
So write down that one also, and then start writing the question, these examples.
Done, sir.
Okay.
Done, sir.
So what's the answer for question number three? Will it is it following the law of conservation of mass or not? So let me explain you this one more.
I'm done.
Have you noted this one that this is not following the law of conservation of mass? If you write unbalanced chemical equilibrium,
I
it will
wrote
not follow.
the
Okay, everyone noted
yeah.
that this is
Yes,
not
sir.
following the law of conservation of mass. Next, moving to this one is, let's suppose if you have 5.3 grams of sodium carbonate in a 2CO3. Okay, and it is reacting with 6 gram of ethanoic acid. Ethanoic, you can write the formula because you don't, sorry, you can't write the formula because you don't know the formula of this substances. So it's okay. You can write the name sodium carbonate, sodium carbonate. Okay, and it is treated with 6 gram of ethanoic acid. So write ethanoic acid. So then it gets you carbon dioxide, CO2, like CO2, water, and sodium ethanoate. Sodium ethanoate. Ethanoate. If I have sodium carbonate is 6 gram, um, and it is reacting with ethanoic acid, which is no, 5.3 gram is sodium carbonate. So it is 5.3 grams of sodium carbonate is treated with 6 gram of this one will gives you 2.2 grams of this one and 0.9 gram of this one and 8.2 grams of this one. समझ आया?
Yes, sir.
So what you will get a total here as 11.3, total as 11.3, and when you add this all you will also get 11.3. So since it is following the law of conservation of mass, hence so you can write it according to the law of conservation of mass. ये reactant है ये product ऐसे लिखो इसको यहाँ से, and you will see that the both are then getting the reactant and product sides are equal, so it is following the law of conservation of mass. So start writing it please fast.
So can you show the question?
Oh, पूछ लेंगे आपने.
Done, sir.
Start adding this one please. You done?
Yes, sir. No, sir. No, sir.
No. Let me do.
Yes, sir. Done.
I'm done.
Oh,
Done, sir.
the next is law of constant proportion. What does this law of constant proportion says? The law of constant proportion says that in a chemical compounds, elements are chemically combined together in a fixed ratio by mass. In a pure chemical compound, always contains same element combined in combined together in same proportion by mass, irrespective of the where it is taken. But you can write the simplest definition here from just writing. What does the law of constant proportion state? State that state that in a chemical compounds, elements are chemically combined together in a fixed ratio by mass, in a fixed ratio by mass. Okay, note it down fast. Note it down fast. In a fixed ratio by mass. According to this one. ये क्या कहता है? I'm going to explain you.
Done, sir.
Okay. Now we shall be moving here. That is now what does this law of constant proportion means? What does this law of constant proportion means? So law of constant proportion state that irrespective of the source from where you are taken, whether it is the water of you are taking from river water, you are taking the water from pond water or the lake water or the rain water or the ocean water. If you are taking water, it will be always 18 gram. For every 18 gram of water will have six because water is made up of H2 and O. There will be 2 gram of hydrogen and 16 gram of oxygen. And you cut it, you will get 1 is to 8. The simplest ratio for water is 1 is to 8. So for every 9 gram of water, if you have 9 gram of water, you will have 1 gram of hydrogen and 8 gram of oxygen will be required. If you have 80, then you double it. 1 is to 8, you have 18, so you have 2 is to 16 ratio. So if you have 36 gram, then you will have 4 is to 30, 4 is to 32. So irrespective of the source from where you are taken, you will always have the ratio of hydrogen to oxygen is 1 to 8. Okay. Like for example, if I'm taking the example of that I'm taking the examples. This I have already explained you in the atoms and molecule chapter. That in the atoms and molecule chapter I have already explained that if you are having H2 plus O2 will gives you H2O. So it is not H2O2. Why it is not H2O2? Because the formula of water is H2O. Now, if we balance it, This now it is 2 hydrogen, it is 2 water molecules. Now it is 4 hydrogen atoms. 4 into 1 plus 16 into 2 will gives you 2 into 18. We get 36. 36 here. We get 32 and we get 4. Got it? समझ आया?
Yes, sir. Yes,
So you will
sir.
get total mass. But if you simplify it, you will get 1 is to 8. 1 is to 8 is to 9. You divide it by 4, each of them, the whole equation. The simplest ratio for hydrogen and oxygen in water is 1 is to 8. So it can also be changed. Like if you take 0.5 grams of hydrogen, so you need only 4 grams of hydrogen, oxygen to it, and it will give you 4.5 grams of water. So according to the ratio will be same. Like if you take 100 grams of hydrogen gas, then it will require 1 is to 8 ratio. So it will be 800 grams of O2 will be required. And then you will get 900 grams of water. Grams of water will be there. Okay. So it will give some 900 grams of water. So it will always same. The ratio of hydrogen to oxygen in water is always same. Okay, that is called law of constant proportion. Like for example, if you have like if you are having carbon dioxide, C plus O2 will gives you CO2. Now you have 12 grams of carbon and you have 16 grams of oxygen. Sorry, C plus O2 will gives you CO2. You have 12 gram of this one plus 44 grams of, sorry, 32 grams. 32 grams of oxygen will give you 44 grams of carbon dioxide. Okay, समझ आया? समझ आया? You cut it by simplest ratio, you will get 3 is to 8 is to 11. So for every 3 grams of this one, you will get 8 grams of, you require 8 grams of oxygen only, and it will give you 11 grams of carbon dioxide. But instead of 6 gram, instead of 3 grams, if you take 6 gram of this one and 8 gram of this one, can you tell me that how many grams of carbon dioxide will be found? Because I have taught you this one in the previous class. Can you tell me that how many grams of carbon dioxide will be found? Anybody in the class? Hmm? No, it will not form 14 grams. It will still form 11 grams. Because for 8 gram, we require only 3 grams of carbon. So 3 out of the 6 gram, 3 gram will be reacted to form 11 grams of carbon dioxide. But remaining 6 gram out of 6 means from 6, 3 has been used and 3 will remain unreacted. Okay. Because for the next 3, there is no oxygen. Got it? If you want to completely react 6 gram, then you need extra 8 gram of for the next 3 grams. Okay. Got it? समझ आया? इसको मैं बहुत ही
Yes, sir.
प्रैक्टिस कराऊंगा, बहुत ज्यादा प्रैक्टिस कराऊंगा इस चीज को. सो इट विल टेक टाइम. ओके, डोंट वरी. आज पहला दिन है इसका, तो कोई इशू नहीं है. ओके, तो स्टार्ट राइटिंग दिस वन प्लीज फास्ट. स्टार्ट राइटिंग. You done? All of you noted? Should I
No,
move forward?
No, sir.
Write down. This. From the above three cases, differently weighed water molecules we have taken, we find that the hydrogen to oxygen ratio is always 1:8, proving that it is a log function.
I'm done.
Let, let's wait for other students.
Done.
Write down this question. Hydrogen oxygen combine in a ratio of 1:8 by mass. That mass of oxygen will be required to completely react with 3 grams of hydrogen. Note down this one, please. Noted?
No, sir.
Noted first. Okay, done. चलो कितना आंसर आया इसका? What is the answer? So you know that H2 plus O2 will gives you H2O. And you know that the ratio is 1:8. Get 9 gram of water. So if you are having 3 grams of hydrogen, so how many grams of this will be required? So 3 times of this one will be required. That will be 24. So, and it will gives you 9 plus 3, 27 grams of water. समझ आया? समझ आया? Yes
Yeah.
or no? So you can do it like this way. Like this way. Do it. You noted?
Yes, sir. No, sir.
Everyone?
No, sir. Just a minute.
No.
I'm done.
Okay. Done, everyone?
Yes,
Let's
sir.
start right now. Let you start. I'm saying that N2 plus 3H2 gives you 2NH3. The simplest ratio of this one is 14:3:17. Then simplest ratio is given here. Then calculate calculate the amount of H2 require and amount of ammonia form. Amount of ammonia form. Ammonia is this one. Okay, this is ammonia. Ammonia formed when 0.35 grams of N2 react with H2 with sufficient H2. With sufficient H2. Okay. So you have to tell me the answer that if you have 0.35 grams of N2 gas, then how much grams of hydrogen will be required for to completely react with this 0.35 grams of the sun? And also tell me that how much grams of ammonia is going to form? Just tell me. You done? Noted?
Yes, yes, sir.
What's the answer? Is your answer first?
Sir, is H2O 0.75? 0.075.
0.075. Let me check. So first of all, what you are going to do is you will put that given amount here as that is given to you, that is 0.35, and then put that value as x because you need to find out this value. So write 14 upon 0.35 is equals to 3 upon x. Now simply you have to find out the value of x. So you can cut it, remove the decimal, get 100 here. I can get it 7 twos are and 7 fives are. 5 ones are, 5 twenties are. Simply, you will get 5 twenty, 7 numbers, 7. Okay. So you get 40 here. 40 is equals to 3 upon x. X will be equals to 3 upon 40. We go to that side, it comes to downside. So when we divide 3 by 4, we will get 0.75. But when we divide 40 by 3, we will get the decimal will shift or one digit to this one, 0.07. So x is 0.07. समझ आया?
Sir.
And the amount of ammonia found will be, because H is the hydrogen, that is 0.07, and here you are having 0.35 grams of nitrogen. Add these two both and the sum will be, you will get that value. Okay, समझ आया?
Yes, sir.
So so next question, if I'm going to give you, calculate amount of CO2 produced when when P 3 gram, or not 3, 0.3 gram, 0.3 gram of carbon is burned in the presence of sufficient oxygen. Oxygen 0.3 grams. So C plus O2 will give CO2. I'm saying the mass of one oxygen atom is 16, one carbon atom is 12. Okay. Then find out the original ratio first and then try to find out. You done?
No, sir.
Can I help you or you will be still you are doing?
So can you solve it? It's not.
First of all, check whether this reaction is balanced. One carbon is here, one carbon is here. Two oxygen is there, two oxygen is there. So it is balanced. Now put the mass. The carbon mass is 12. Oxygen mass, one oxygen atom is 16. So there are two oxygen atoms. O2 means two oxygen atoms. So it will be 32. It will be 32. Got it? It will be 32. Now, what you are going to do is, and you check it, the mass of carbon dioxide will be C plus O2 is CO2 total. 12 plus 32, you will get 44. So 44 is the mass of this carbon. If you find the simplest ratio and you cut it all by 3, 4, sorry, you will get 4 3 are 12, 4 is the 32, and 4 11 is the 42. So this is 3 plus 8 is 11. You should check that whether the sum of these ratios is equal to this one or not, if it is a single column. Okay, got it? Now what you need to do is, it is asking for the zero point 0.3 grams of carbon is burning with sufficient supply of oxygen. So asking the amount of CO2 produced. So 0.3 grams. How it is X? So right here, 0.3. 0.3. And it is not asking the amount of carbon dioxide required. Sorry, oxygen required. It is asking that amount of CO2 formed. So for 0.3, you need to find out the value of this one. X. How many grams of carbon dioxide will come if you have only 0.3 and you have sufficient supply of oxygen. Means whatever amount of oxygen is required, it is there. Sufficient. So what you need to do is next. You write 0.3 and you write 3 upon 0.3 because the ratio is 3 upon this one is equals to 11 by x. Let's check it. 3 upon 0.3 is equals to 11 by x. Don't write x. Don't write this one because it is not being asked. Okay, now what you need to do is you need to find out the values. Try to find out the value of x. You done?
Yes, sir.
What's the answer?
1.1.
1.1. Yes, it will be simple 1.1. You can reciprocal this one also. Like this, you will get x by 11 would be equals to 0.3 by. You remove the decimal, you will get 10 here. But 3 by 3. And this 11 will come to this side, you will get x is equals to 11 by 10. But x is equals to 1.1. 1.1 grams of fluid will be formed. Okay.